Hello guys, so nandito na naman ako para sa isa na namang lecture sa fluid mechanics. So ang topic ko ngayon is analysis of dam. Okay, so meron tayo ngayon dam dito and ito yung ating upstream. Okay, so ito yung ating upstream side. Then yung kabila naman yung ating downstream. So pwede rin tayo magkaroon ng liquid dun sa kabilang side, no? So, let's say, halimbawa lang yun. So, pwede tayo magkaroon dyan. Okay? So, ano-ano forces yung involved sa ating dam? So, of course, yung weight ng dam itself. Okay? So, meron tayong weight. And, meron din tayong hydrostatic force. Okay? So, kung naka-incline yung face, yung upstream face nung gate, like in this example, okay, then ito yung ating liquid, then yung ating hydrostatic force, alam natin, is naka-perpendicular doon sa ating surface. Pero instead na kunin natin yung total hydrostatic force, so tulad sa hydrostatic force on curved surface, so, inahati natin siya sa dalawa, no? So, meron tayong vertical component, so, which is equal dun sa weight nito, volume of liquid na to. Okay? And yung ating horizontal component ng hydrostatic force, FH, so, which is yung force acting dito sa vertical plane, or dito sa vertical projection nitong ating ng face ng dam. Okay? So, ano ba nangyayari sa dam kapag na-apply siya ng mga forces na to? Okay? So, ang tendency is either mag-slide yung ating dam. Okay? So, if yung horizontal forces natin, especially itong hydrostatic force, is mas malaki doon sa ating friction force. Okay? So, another possibility is tumumba yung dam natin and mag-rotate siya about this point. Okay? So, this point is yung tinatawag nating toe. Namang point na to, tinatawag nating heel. So, parang sa paa lang. Okay? So, toe and heel. So, because of the horizontal force F, okay, so magkakos yan ng moment about point B. So, itong moment na ito is yung tinatawag nating overturning moment. Okay, so overturning. So, tinutumba niya yung dam. Okay, and ano yung nagme-maintain doon sa dam to be in its static position? So, of course, itong weight. So, yung weight naman will cause another moment opposite in direction ng overturning moment. So, ang tawag naman natin dito is righting moment, or para mas madali natin maintindihan, righting. So, itinatama niya yung position ng dam. Okay? So, of course, obviously, dapat mas malaki yung righting moment as compared doon sa ating overturning moment. And with regards naman sa friction, so, mas malaki dapat yung ating friction force as compared doon sa horizontal forces natin. Okay. So, ano pang force yung maaaring dalhin, okay, ng ating dam? So, yun naman yung tinatawag nating uplift forces. So, yung uplift force is, okay, so normally, so, halimbawa, wala muna tong water to sa kabilang side. Okay, so, madalas na sinasabi sa problem, it varies linearly to full hydrostatic pressure at the heel, then 0 doon sa toe natin. So meaning, when we say maximum hydrostatic pressure, so dahil meron tayong depth of water dito sa upstream side, so at this point, okay, so dito sa point na to, meron tayong pressure na equal sa unit weight ng water times nung height. Okay? Itong height na to. Okay? So kapag sinabing maximum pressure at the heel, so meaning yung soil is, sabi nating permeable talaga, okay? And yung pressure na yon is nakasip in dito sa ilalim na to, okay, ng ating dam. So ang pressure dyan is sinasabi nga is maximum. And then bakit siya nagba-vary from maximum pressure to 0 dito sa toe? Okay, so dahil walang tubig dito, so kung meron man nakasip in dito na mga liquid or water molecules, then eventually nade-drain naman sila dito sa labas. Okay, so pwede silang kumatas na dyan. So hindi sila nag-cause para magkaroon ng, sabi nating, flooding dito sa kabilang side na to. Then kung kukunin natin pressure at this level, so wala tayong height, then pressure at the toe is 0. Okay, so another scenario naman is kung meron tayong bagawin ko lang to, no? Okay, so kung meron tayong liquid din sa kabilang side, so pwede rin namang maximum hydrostatic pressure. So this is yung heel, nandito yung toe. So kapag maximum hydrostatic pressure sa heel, pwede rin namang maximum pressure dun sa toe, pero since iba yung level, iba yung depth ng water dito sa kabilang side, if this is, let's call this H1, then let's call this H2. Okay, then ang pressure natin dito is unit weight ng water times ng H1, then ito naman is unit weight ng water times H2, then that will vary linearly. Okay, this uplift force U will cause what moment? So diba, that is dito tayo moment sa toe, so that will cause overturning, so additional overturning moment. Okay, so kaya as much as possible nililimit natin kung yung magnitude ng uplift force, kung meron man, kung hindi man maiwasan, so nire-reduce natin. So pwede na sabihin na, okay, so since this varies linearly from maximum, so this is unit weight ng water times ng height, okay, then 0 tayo dito sa point B sa toe, then yung uplift force, okay, is simply equal to sa volume nitong pressure diagram. Okay, so mamaya magkaroon tayo ng example. And since this is triangular, then this is 1/3 ng base, then yung kabilang side of course is 2/3 ng base. Okay, so pwede rin naman sabihin sa problem na no uplift force dun sa bottom ng dam, then so i-disregard mo lang tong uplift force U. Okay, so para mas madali yung pag-solve ng mga kailangan natin, so dinidivide natin yung kinukuha natin yung mga weights and yung mga forces natin in terms of smaller components or smaller parts. So let's say, kasi kung etong buong area na to, pwede naman if you know the centroid of this area, so kunin mo yung total weight, then dapat alam mo yung distance x. Okay, so let's say we have distance x from the toe. Okay, so lahat ng moments natin is galing dito sa toe. So definitely mas mahirap ma-locate yung centroid ng ganitong shape. So ang gagawin natin is, ginagawa natin is to divide this area to a more common, into smaller shapes and yung mga common na shapes. So bala ka kung paano mo i-divide. So let's say ganito, no? Meron akong rectangle or square or rectangular, then another rectangular. Okay, so may triangular dito na weight, may rectangular. So kapag ganyan na breakdown natin siya into rectangular and triangular shapes, so mas madali natin malocate or ma-determine yung mga distances ng mga forces na yon from our toe. Okay? So if this is F1, F2, F3, F4, then this is X1. Ito naman is consider kong X2, X3, then this is X4. Okay? Then of course, yung weight ng water dito sa upstream side will also produce downward force na somehow matutulak pa rin doon sa dam to maintain its yung design position niya. Okay? So eto, this volume of water will also cause, so tawagin na lang natin itong weight or so F kasi nilagay ko, no? So F or weight, pwede naman yun. F5. Okay? Or FV1 para sa vertical force, FV2, and so, etc. Okay? So, kasama to doon sa magkakos ng righting moment. Yung weight ng water na yun. So, ganun din dito. Dito sa example na to. So, yung overturning moments natin in this example will be produced by this hydrostatic force F, FH, and yung ating uplift force U. Okay, so we have to determine lang yung location nila or yung mga distances or moment arm from the toe or from this point. Okay, so in terms of soil pressure, okay, so normally hinahati natin to into 3 parts. So meron tayong tinatawag na middle third. Ito. And so yun lang naman, middle third or outside ng middle third. Okay? Okay, so if meron tayong, so nakita natin kanina na marami tayong mga forces, mga downward forces, meron tayong vertical force and horizontal forces. Okay? Then, all those forces will produce a resultant force. Okay? So, magkakaroon tayo ng resultant force. So, let's say meron tayong force acting on this direction. Okay? Nakikita pa ba? Gawin ko na lang okay. So, yan yung ating resultant force F. Then, kung may resultant, meron tayong of course reaction. Okay? So, yan na yung total ayun nga, resultant ng lahat ng mga forces acting doon sa gate. Okay? Then, meron siya, of course, na component. Meron tong horizontal component and of course, meron din tong vertical component. So, sa reaction naman natin, so meron din tayong vertical reaction, RY. Then, meron tayong horizontal reaction, R sub X. Okay. So, consider natin muna itong isang, let's say, isang column. Then, nilagyan mo siya ng force sa gitna. Then, alam natin na that will be under compressive stress dahil sa compressive force. And yung pressure diagram natin will be uniform. Okay? If we divide natin ang area, okay, then yung pressure natin is uniform. So, same thing din kapag, halimbawa, meron tayong beam, meron tayong uniformly distributed load. di ba yung resultant is acting dito sa gitna. If that is uniformly distributed load, then yung resultant natin is nasa gitna. Okay? So, in this case, kung yung resultant force F is acting dito sa gitna, pinakagitna ng area, ng bottom, ng gate, then yung ating pressure, yung soil pressure natin will be uniform. Okay? Pero if meron siyang distance from the center, so tawagin natin tong distance E. Meron siyang eccentricity. Okay? So, kung na-discuss na sa inyo, umabot na kayo sa strength of materials, yung bending stress is equal to MC over I, where M is yung moment, then yung C is yung distance from the centroid to the farthest fiber. Okay? And yung I is yung moment of inertia about the center of gravity nung area na kino-consider natin. Okay? And yung actual force because of the downward force, yung stress natin is yung, so kino-consider kasi nating negative if compression, diba, sa strength of materials, and that is force P over A. Okay? If i-combine natin yung dalawang stresses na yan, okay, so that is P over A, then plus minus ng MC over I. So, ito rin yung ina-apply natin sa dam. So, ang difference lang is, if meron tayong isang material, meron tayong column, so meron siyang actual load, then meron siyang moment. Okay? So, depende sa magnitude ng moment, yung stress diagram natin sa column is pwedeng maging, kung wala kang moment, again, that is uniform, yung pressure diagram. Kapag meron kang moment, so yung pressure na to is parang superimpose mo dito yung yan. So, meron tayong positive moment, yan yung sa tension side, negative moment, negative stress, dito naman ito yung negative, ito yung positive. Okay? So, kapag isinubtract natin yan dito, so yung pressure diagram ng column is pwedeng maging ganito yung shape, trapezoidal. Okay? And if lumaki pa yung moment, so pwede siyang, so either may moment M siya, nasa gitna yung force P, or yung force P is i-move mo dito. Kung i-move mo siya dyan, magkakaroon siya ng distance E, then yung moment mo, i-move ko lang to. Then yung moment natin in this case is yung P times yung distance E. Okay? So, kung titingnan natin yung, di ba, pag meron tayong distributed load, meron tayong triangular na distributed load. Okay. So, alam natin na yung resultant nito is, this is 1/3 nung distance, nung length, then this is 2/3 nung length. Okay, so alam natin yan. So, if yung location nitong P is nasa 1/3 nito, okay, so ano yung na-expect nating moment diagram dito? Or yung pressure diagram? So, triangular. Okay? So, if this is located sa 1/3 nung, let's say, nung width B, itong column, then itong kabila is 2/3. Okay? Then, yung pressure natin will be triangular. So, same lang dito. Okay. So, kapag mas malayo pa or mas malaki pa yung moment, so, pwedeng yung pressure, yung stress diagram natin sa column is maging ganito. So, pwedeng ganito. No? Let's say ito yung compression. Ito naman is tension naman doon sa kabilang side. So, alam natin yun na kapag may bending. So, meron tayong compression side, meron tayong tension side. So, kung masyadong malaki yung moment, malaki yung tensile stress doon sa isang side nung column natin or nung member, then ma-overcome niya yung yung compression ng actual force P. Pero sa footing or sa foundation or sa dam, okay, sa pagdating sa dam, hindi natin kino-consider yung tension doon sa soil pressure natin. Kasi nga nakapatong lang naman tayo dun sa soil. Okay? So, kaya importante na malaman natin kung saan located yung ating resultant force. Okay. So, if yung resultant force natin falls within the middle third, okay? So, yung pressure diagram natin is magiging ganito. Okay, so trapezoidal. So, kung saan mas malapit yung force, yung resultant, so doon mas malaki yung soil pressure. So, meron tayong maximum and of course, meron tayong minimum. Okay? And if yung vertical, yung resultant force nung do sa dam falls exactly doon sa middle third. Okay? So, halimbawa, no? Dito siya sumakto sa may middle third. Okay, so first ito yung resultant force, ito yung ating vertical component. Okay? Then yung soil pressure natin will be triangular. Ayan. So, triangular. So, nandito pa rin yung Q max. Then, nandito yung, so, 0 yung pressure natin ngayon dito. Okay? So, paano kung mas lumayo pa dito? Let's say, umabot dito yung resultant force dito sa point na to. Lumampas siya dun sa middle third. Then, hindi magiging ganito yung natin, no? Okay? Yung pressure diagram. Kasi hindi tayo magte-tension dito sa side na to. So, ang i-consider lang natin is yung compression na pressure dun sa soil. Okay? Then, so, ano yung naging difference niya daw kapag lumampas para tayo dun sa middle third? Ang mangyayari is, yung area under compression, so initially doon sa unang two examples natin, so yung area na kino-consider natin is yung buong ilalim ng dam. So if lumayo masyado yung ating resultant, lumampas tayo sa middle third, then yung area na kino-consider natin under compressive stress is lumiliit. Okay? So kaya nag-iiba na yung formula natin doon. So, di ba, meron tayong formula, I'm sure na-discuss din sa inyo sa mga lectures sa inyo, is yung soil pressure is yung resultant force Ry, yung reaction or resultant, same lang naman yan. Same lang naman tong R and itong yung resultant force F over B. So, actually, times, so every 1 meter kasi tayo, di ba, na strip nung dam. Then this will be multiplied by 1 plus 6E over B. Okay, so meron tayong ganyang formula. So may isa pang formula, hindi ko masyadong kabisado pero pwede nating ma-derive yon. Okay, so let's try to derive yung formula na nakikita natin sa mga book. Okay? So, solving for Q, soil pressure, maximum or minimum. So, again, that is yung actual force, yung compressive force due to the vertical forces, yung mga weights natin Okay, so lahat, pati yung weight ng water na nandito, di ba, kasama yon. Okay, so lahat ng vertical component natin is the same lang nung reaction y, yung vertical reaction. Okay, so Ry, or pwedeng ito yung total resultant na total vertical forces natin na downwards over nung area. So, ano yung area natin? So, itong length B, yung width ng dam sa ilalim. So, understood na yun na times 1 meter tayo. So, kaya pwedeng hindi na natin siya sinulat. So, 1 meter width perpendicular dun sa screen. Okay? Then, plus or minus. So, kung napansin natin, from uniform, pwede tayong yung stress, pwede mabawasan, and pwede rin siyang madagdagan yung compressive stress doon sa bottom ng dam. Okay? So, kaya nagiging trapezoidal or triangular yung shape. So, plus or minus ng MC over I. So, alisin na natin yung 1 meter, no? Then, yung moment natin, so, tulad ng sinabi ko kanina, so, since yung vertical component nitong ating resultant force is merong distance E from the center, so, magkakaroon tayo ng eccentricity. So, yan yung ating moment. So, yung moment natin is Ry times E. Okay? Then, yung distance, yung C, yung distance C. So, that is from the center nung dam papunta dun sa pinakamalayo. Okay? So, same distance lang naman yan either side. So, which is B over 2. Okay? Then, moment of inertia. So, saan ba tayo kumukuha ng moment of inertia? So, kung titingnan kasi natin yung ilalim ng dam natin. Okay? So, this is 1 meter, no? And, so, ang kinoconsider nating axis nung sa moment is etong axis na to. Okay? So, dyan tayo so, patong point na to. Yeah, so, parang yan yung ating axis. So, ito yung tatawagin natin, so, di ba moment of inertia ng rectangular sa center of gravity is BH cube over 12. Ito yung consider natin B, ito yung consider natin H. Pero this is 1 meter, and itong H na to, ito yung ating width ng beam, which is yung B nga. Okay? Ito yung length ng beam. Okay, so moment of inertia is 1. Then yung H cube is yung B cube over 12. So, simplify natin. Okay. RYE. Ito, pag kinancel natin, 2 over 2, then sa denominator over 12, so magiging 6 to. And etong 6 na to is pwede nating ilagay dun sa taas. Okay? Over 6. Then, sa denominator, so cancel yung isang B. So, magiging B squared. Okay? Over B squared. So, ito yung ating Q. So, solving for soil pressure, pwede natin i-factor out yung Ry over B. Ito, Ry over B. Ry over, so isang B lang, so may iwan pang isang B doon sa term na yon. Okay, so factor out natin Ry over B multiply by, so na-factor out na natin to, so matitira is 1. Then plus or minus ng 6E over, so naiwan pa ng isang B dun sa loob. So, ito yung ating formula. If yung load natin falls within the middle third, or pwede rin siya kahit magsakto siya dun sa middle third. Okay? So, paano naman kung lumampas yung resultant force natin sa middle third? So, ito na nga yung matitira, no? Itong area na to. itong naka-green. So, yun lang yung i-consider nating pressure diagram. Okay? So, tulad nga nung binanggit ko kanina, yung sa resultant, kung meron tayong triangular load sa taas. So, etong resultant force natin na to, di ba, equivalent yan dito sa area nitong triangle. Okay? In this case lang, yung sa atin, yung force, yung resultant force, yung vertical force, Ry, is equivalent doon sa, actually that's volume naman, nung pressure diagram. Okay? So, regardless kung trapezoidal siya or triangular, tulad nito kapag lumampas tayo sa middle third. Okay? Okay? So, paano natin malalaman na lumampas tayo doon sa middle third? So, di ba may formula na tayo doon that yung x bar, so which is yung location nitong ito, no? So, pwedeng yan yung x bar, pwedeng ito, pwedeng etong orange na to. So, depende nga kung saan yung na-compute nating, ano yung na-compute nating value ng x bar. Pero solving for x bar, again, nasa lectures nyo naman yan. So, that is yung writing moment minus nung overturning moment. Okay? Then, over ng yung Ry. Okay? So, ano lang naman yan, summation lang ng parang wala naman pinakaiba sa pagkuha ng resultant force, di ba? Paano natin kinukuha yung resultant force? So, yung F x bar is equal to yung summation ng product ng mga moments ng force F and yung mga distances x. So, F1, x1, F2, x2, etc. So, dito lang din naman ang galing yan. Okay? So, kapag nakuha natin yung x bar and na-determine nga natin na lumampas siya sa middle third. Okay? So, ito na nga yung itong naka-highlight na to. Ito na nga yung magiging shape ng ating pressure diagram. So, since this is triangular, then alam natin na if this is yung, let's call this distance A, which is yung base ng triangle, then yung x bar is A over 3. Tama? A over 3. So, solving for A, which is yung base ng triangle, that is 3 times ng x bar. Okay. So, makukuha natin yung value ng Ry. Then, this should be equal to yung volume ng triangle na yon. Okay? So, yung volume ng triangle. So, that is 1/2. Okay? So, etong height ng triangle is yung soil pressure. In this case, yung maximum pressure. 1/2 ng maximum soil pressure. Yan yung height ng triangle times ng base. So, yung base natin is yung A, which is equal to 3x. Then, yung width natin na understood na meron tayong 1 meter. Okay? So, solving for Qmax, maximum soil pressure. So, etong 2 is itataas natin doon. So, 2 Ry over, so, ito naman is i-cross multiply natin, mapupunta sa denominator ng Ry over 3x bar. Yan. So, meron na tayong formulang ganito. Yan. So, doon siya na-derive. Okay? So, kung alam niyo yung formula, so, mabuti. Kung hindi, so, at least alam natin saan siya nanggaling. Okay. So, I think I have to stop muna dito na medyo mahaba yung derivation natin. Then, antayin nyo lang yung example. Okay? So, I will upload it shortly lang. Okay, so hopefully within this weekend or this holiday and habang bumabagyo. Okay, so again, that's it for now. I hope na linawan kung hindi pa kayo nalilinawan to sa mga formulas na. So, hindi ko na in-elaborate lahat dahil meron naman kayo, I believe, sa mga lectures nyo. So, I think ito yung medyo nakakalitong part. Okay? So, yung mga forces, weight, madali lang yan eh. Yung weight is divide specific weight ng material times its volume. So, ilang naman. So, mapa-concrete yan or yung water katulad dito sa part na to. Okay, so unit weight times the volume lang naman. Okay? So, again, that's it for now. Para hindi masyadong mahaba yung isang video natin. So, I'll be back with an example. Okay, so goodbye and stay safe.